All right, let's take a look at review problem 4.10. We have a point xy that is chosen from this region. And let me just draw the region. We have the x-coordinates must lie between -2 and +2. And the y-coordinate lies between 0 and the parabola y equals x squared. And so the point xy is chosen at random, and I didn't do a good job here, but let's just move the points. Is chosen at random from the shaded region here. Find the expected value of x given capital Y, and find the expected value of y given x. Now it turns out that both of these can be guessed for this picture. However, I'm not going to give you those guesses quite yet. Instead, I'll do the calculations, and then we'll talk about how we could have guessed those answers later. All right, now it's uniformly distributed, so to find the PDF, we first find the area, and the area under the curve is equal to integral from -2 to 2 of x squared dx, which is 1/3 x cubed, evaluated from 2 to -2. And then just simply doing the arithmetic, we get that the area is equal to 16/3. And therefore, the joint PDF of x and y is going to be the reciprocal of the area, which is 3/16. And that's as long as the point xy is inside of this region someplace. Okay, now to figure out the conditional expectation, I need to get the conditional distribution. To get the conditional distribution, I need to first get the marginals. So let's figure out the marginal densities. Okay, so what is the marginal density of x? Well, the marginal density of x, I fix a value of x, and then I integrate over the possible values of y. And so that'll be integral from 0 to x squared of the joint PDF, 3/16 dy. So that'll be 3/16 y, evaluated from x squared to 0. And so we get 3/16 x squared. And the possible values of x go from -2 to +2. To get the the marginal density for y, so we fix a value of y, and then we integrate over the possible values of x, which are on the right side and on the left side. So this side goes from -2 to negative square root of x, and this side goes from square root of x to 2. Square root of y. So -2 to negative square root of y, and then from square root of y to 2. So integral from -2 to negative square root of y of 3/16 dx, plus the integral from square root of y to 2 of 3/16 dx. And then just doing the integrals, we work this out to be 3/8 times 2 minus the square root of y. And the values of y, the lower limit is 0, and the upper limit will be 2 squared, or 4. So the values of y are from 0 to 4. Okay, so that's the marginal densities. So first off, let's figure out the conditional distribution of x given y. Now that will be equal to the joint PDF divided by the marginal PDF for y, and so that works out to be 3/16 divided by 3/8 times 2 minus the square root of y. And so that's equal to 1/2 times 2 minus the square root of y. Now what are the possible values of x for this? Well, the possible values of x, if y is fixed, x must be in one of these two lines here. So that'll be that square root of y is less than or equal to absolute value of x less than or equal to 2. So x could be between -2 and negative square root of y, or x could be between square root of y and 2. So therefore, we compute the expected value of x given y, to be equal to, well, let's figure out the expected value of x for this conditional distribution. So this will be equal to integral from -2 to negative square root of y of 1 over 2 minus, or 2 times 2 minus square root of y times x dx. Then the other one will be square root of y to 2 of the same thing, x times the conditional PDF dx. Okay, so let's go ahead and do these integrals. We get, now in these problems, y is fixed, and I should have written here to be more explicit that capital Y is equal to little y. In these integrals, the value of y is fixed, x is the integral, or is the thing being integrated, and so we get x squared over 4 times 2 minus the square root of y, evaluated from negative square root of y on top to -2, plus the integral from, x squared over 4 times 2 minus the square root of y, from 2 to square root of y. So plugging in, we get, let's see, if we plug in here, we get y over 4, 2 minus square root of y. Plugging in -2, we get 4 over 4, 2 minus square root of y. On this one, if we plug in 2, we get 4 over 4, 2 minus square root of y. On the last one, plug in square root of y, we get y over 4, 2 minus square root of y. And everything cancels, and we get simply 0. And so therefore we conclude that the expected value of x given capital Y is merely equal to 0. So that's one problem. The second part of the problem asks us to figure out the expected value of y given x. So to do that, we find the conditional distribution of y given x. So that's equal to the joint PDF divided by the marginal PDF for x. So let's see. So the joint PDF is 3/16. The marginal PDF for f is 3/16 x squared. So we get 3/16 divided by 3/16 x squared. And so that's equal to 1 over x squared. Now we remember that this is a function of y. And so the values of y, if I take a look back at here, the value of x is fixed, the value of y goes from here to here. So the values of y go between 0 and x squared. And I recognize this to be a uniform distribution with parameters 0 and x squared. So if I directly do the integral, we get the expected value, or directly do the expectation, the expected value of y, given that capital X is equal to x, will be equal to the integral from 0 to x squared of y times 1 over x squared dy. So integrating with respect to y, we get the 1 over x squared comes out. We get y squared over 2, evaluated from x squared to 0. So we get x the fourth minus 0 over 2 times the extra 1 over x squared, and that is 1/2 x squared. So the expected value of y, given that capital X is equal to little x, is equal to 1/2 x squared. And so if I eliminate the equals x here, the expected value of y, given capital X, is the random variable 1/2 x squared. Okay, and so that's our answer. Now at the start of the video I teased that this particular problem, we could have guessed this without doing any work. So let's take a look back at the picture. So first off, suppose the value of y is known. Then this thing is uniformly distributed. So this part out here balances this part over here. So if I have something that is uniformly distributed over both of these things, it can be equally likely to be here or here, then the average clearly has to be 0 by symmetry. Next, if the value of x is known, then the values of y are uniformly distributed between here and here, and so the midpoint would be my guess for the expected value of y given x. So for this particular problem, I could have guessed the answer using the fact that it was uniformly distributed on this oddly shaped region.